Hi guys, today we're going to take a look at pages 12 and 13 of the Unit 9 Classwork packet. The topic for today is the angle of elevation and the angle of depression. Here's how these things work. At the bottom of a diagram, we're going to draw the ground, okay? So for the purposes of this discussion, the ground is going to be flat. At the top of a diagram, we're going to draw the sky. Again, I know the sky doesn't really have boundaries necessarily, right? But for all intents and purposes, we're going to think of it as flat. Now, notice that the ground, at least in theory, is parallel to the sky, okay? Now, what we're going to do is we're going to draw a line that connects the ground and the sky, and we're going to draw it at an angle. This angle right here is called the angle of elevation. It's called the angle of elevation because it's formed by the ground and the sky, and it looks up. By contrast, this angle right here is going to be called the angle of depression. I'll draw a little frowny face for you, okay? The angle of depression because it's looking down from the sky, and that's important. It's formed from the sky looking downward. Now notice that these two angles happen to be congruent by alternate interior angles. When I have two lines that are cut through by a transversal, alternate interior angles are congruent, right? So any angle of elevation problem can be automatically redrawn as an angle of depression problem, and any angle of depression problem can automatically be redrawn as an angle of elevation problem. Let's take a look together at a few examples of how this might work. The first problem we're going to take a look at is page 12, and we're going to look at number 1. Okay. Casey sights the top of an 84-foot high lighthouse. Okay, so hold on a sec. Here's Casey. Here's a lighthouse. Sorry for the lack of originality. Okay, and it's 84 feet tall. And the angle of elevation is 58. Now it says that Casey's 6 feet tall, right? So I'm going to take him 6 feet. And it says that the angle of elevation is 58. Now, some of you guys might have questions about why I drew the line starting from the top of his head and not from the ground. Think about it, guys. Where do you see from? Do you see from your feet or do you see from your eyes? You obviously see from your eyes, right? So therefore, we're going to have to account for this 6 feet when we are drawing our diagram. So that means that this right over here is not actually 84. This piece would just be 78. How did I get that? 84 minus 6. Now, what they're asking us for is how far is he standing from the base of the lighthouse? Here's him, here's the base. So they want to know this. Okay, is this a trig problem or an inverse trig problem? Because they're asking me for a side, it's going to be a regular trig problem. This right here is opposite, this is adjacent, so this is going to be a tangent problem. Let's set up the ratio. Tan 58 equals 78 over x. To get the x off the bottom, multiply both sides by x to get x tan 58. And then to get rid of a multiply tan 58, divide both sides by tan 58. And I get 78 over tan 58 equals x. Let's actually find this as a decimal. Alrighty. So I'm going to do 58, hit the tan key. That gives me about 1.6. So I'm going to do 78 over 1.6. And now let's calculate that. 78 divided by 1.6. Hold on. 78 divided by 1.6, 48.75. Bam. So guys, a lot of this is really just going to make sure you're drawing the diagram correctly. If you can draw your diagram correctly, the trig behind it, the trigonometry behind it is actually really not that bad. All right. Let's take a look at an angle of depression example, all right, just to make sure we're okay. And let's take a look at page 13, example number 6. Oh no, my marker. Once again, page 13, example number 6. Alrighty, so a pilot in a helicopter spots a landing pad. Okay, so here's my helicopter. Woo! Okay, so that's a horrible helicopter, but you guys are just gonna have to deal with that, okay? And he spots a landing pad below. Here's my landing pad, okay? Big L. Now, it tells me the angle of depression, okay? So here's my sky. Here's my angle of depression. I think they tell me it was, what, 73 degrees? Yep. And the horizontal distance is 1200. What does horizontal mean? Horizontal means straight across. So this piece right here is 1200, and then I'm gonna bring this straight down, okay, for 90 degrees. Now, what are they asking me for? What's the altitude of the helicopter? What does altitude mean, guys? Altitude is a synonym for height, which means straight up and down. So they're asking me to find this. Bam, let's go. So let's do some labeling, guys. This is opposite, and this is adjacent. So if I have opposite and adjacent, which is the only one of the three trig ratios I can use, that would be TOA, or tan. So let's set up the problem. So tan 73 equals x over 1200. To get rid of the divided 1200, multiply both sides by 1200. Oh my gosh, sorry about that. 1200 tan 73 equals x. And now, using our calculator, let's review how to do this. So I'm going to do 73, hit the tan key, and then multiply it by 1200, and I get 3,925. All right, 3,925. Let's take a look. So that means that the altitude is around 3,925 feet from the ground, which is actually kind of plausible, right? Because helicopters don't fly all that high, but they're not all that close to the ground either. So it's like between a half mile and a mile. All right, cool.